fulo kenda to ni betoto
Benge Congo.
Lamin.
Na.
Lamin te jibe norin te nyamen Lamin.
Kabona wulo kono.
Wulo kono nyinta mo Lamin.
Pa bilenki.
Muna ngata afongole.
Hayna.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumara kan kuma diten.
Fabrama.
Jumara
ndele bare muso.
Lunda mana
Amokata.
Jamani mbere.
Alindo ko.
Jamani
bari ngoto mu kontande.
Bari jamani fana na ramu kontan.
Ngoto mina ka Lamin je fon fileta. Lamin jibe nori nyala.
Lamin ida sama na benke. Yala so do no bo mo ko momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakkilo diata bake karamungoto. Ami santeng ministri ko di ngole si suoko na.
Sibitun.
Bago na ringa.
Alani ko kede namo balo.
Alani na ko na karta bulo be damna alani je.
Ngoto.
Nam.
Ngoto mon kontan fere.
Jamani mu ne keda.
Ite ka Lamin ki wulo ko no nyintay mon ko do fote malo Lamin nyande sila la be la moy kala karango.
Jamani karamol be sorande ne ko fasita wulo ko nako.
Karamol ma so ni ko karamol sorande amaka kom holiday lem. Ngoto. Dini wo nyande sila la ala karango la moy yamen kaben fue. Man kontan andamande.
Allah min kombo courant adan dalla kombo len do jankara mol soro ndal ro gabe courant ma daro lo kombo e don dol fanena kara mol soro je kara mol soro Lamin adara lo ni no la man tara fe na sokon ala mu nek la
am Lamin ite fo de malo ko le de ke kar
Fine.
e ko yaadi mo do ne ya mu na fonye
kabim bina ka ndambita nteri maning Fatu ndambite la sukala ala dinol bebe siri be la moyka
faru daso am fana tambira jere ni subala ngaje dinol be jet talanta nen kili waro e be serin jelet
sa Lamin fanante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo Lamin
aman dara fenela
ite dine ko di man si yakari la suno la moy radio to ba na
mu ne ya fende ma nyaara ni
entel jikot
afende ma mu ne be
ite balantel be jikritel ni man karam ko kile yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide na raje den sonka bay ko Lamin ma ñata la wulo adu karam mo be so afende membe
ko to wole nati bayo ngalle ni Lamin kuntala kombo courant e ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulen ko to batiri sanga ay si ay alamo
sa do kala nyaadi ado kala nyaadi
kamun ke nyaadi
radio abo la mo la be mona falaje
ibe la karandirol kala jele
titalle be radio men ka karandirol
ila subjectol baby jele baby jele
wala nan ka coco moy fa dan so wala ngombe tambi kana ngadi ngol de be ikadum bungo de be kada
ma asototal de
Lamin mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ha ko de ko folle sinila ba ndele sinilo ne ba
mba say mba foke yon koto wole fango yon wulidi yalo famo keta bat ñu fanam bulata ko ko don meyen nati jambi Lamin nyanta karana ndel beji ko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wala ka munda kara mo man soro Lamin nyanta kara si so na radio
la sila le ayala le sino
dale ko korno ko smalo
kilar ya
be bin ko mo mo say mi do ni ko no kera
mengi bruzo
ndelo ko la da ba rosa no radio ba no bari woro radio ni abe je be do ngamra do man dembe buljan dala nyara nyar wo ko fe Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
mengi mun na de
teku
bari ko do famo ke
ja image nañu ñambol si zol le ke je kisgi man si zol no le kafun ka ñowa bari ñambu kino ni mañana ka finde ni nambe ko so la ga
ngalle limbeta de be ñambo do dilanna
ñara nim ko ridin fennat ñara nata
ko bari famo ke da
ngata bungono tammi bungono ñara mel ngando ko fele ko ke e bar nganda ni pelo la ndija
iyo awa betar la
bungono bismillah bisu diara
pendulala yefungo tanka sina dolu tanka koro korota koro korota.
Hello viewers and listeners out there. I'm Mr. Cisse. I'm back on the same lesson on calculus in general, that is derivative rules, powers constant, the sum and difference rule. The alternate method. Depending on the function, calculating the derivative using the format method, that is the first principle method, with limits can be extremely time consuming. Can we imagine calculating the derivative of f of x equals to 17x to the power 9 minus 3x to the power 7 plus 5x to the power 4 minus 2x cubed plus 190. Using that method, or about another format, another function of this format, it is going to be extremely difficult, very difficult for you to be able to write all and then define the derivative of the function to a simplified term. Fortunately, there are some shortcuts which make taking derivatives much easier. So today we're dealing with those shortcuts. Hopefully we're able to finish on time. But in exams, they might still test your knowledge of calculating derivative using the formal method, formal definition or limit method. So your energy, the energy that we use in explaining the previous lesson is still useful. Exploration. Power rule. Let's look back at a few of the derivatives we have calculated already. We found that derivative of 7x squared minus 3x gave us 14x minus 3. And the derivative of 10x squared is 20x. And the derivative of x cubed plus x squared minus 2 also gave us 3x squared plus 2x. What observation can you make? Can you notice any shortcut for finding these derivatives? That is, if you are given a function that is in this format, we have 7x squared minus 3x. When we find the derivative, we got what? 14x minus 3. Using the first principle method or the formal definition method. But what I want you to understand is there are shortcuts. And these shortcuts, to explain it to you, first we have to go through the first principle so that you get some idea, especially that of further maths. It's very important you understand the first principle, because you might be asked a question on find the derivative using the first principle. It's very common. It's regular. So by looking at this, we have 7x squared. 7x squared gave us 14x minus 3. What happened here for us to get this? This pattern that we observe is important because in the next slides, we'll be dealing with them. We have what we call the power rule. If you are given a function, f of x equals to x to the power n, a function that is x to the power n. To find the derivative or the first differential, f prime of x, this will give us the power that we have on top there. The power is what? Power is n. We have f of x is equal to x to the power n. The power that we have there, to find the first prime, that is f prime of x, we'll bring the power down. The power we have there is n. We have n into x. The power that we have will subtract 1 from the power, that is n minus 1. And that's what we have there. F of x is equal to x to the power n. To find the first derivative of f of x, f prime of x, this will give us n into x to the power n minus 1. An example is given. If you have f of x equals to 5x, the first derivative of f of x here, f prime of x, will give us, we'll bring the power of x down in front of x as a coefficient. 5 is down. And the power that we have there, you subtract 1. So 5 minus 1 will give us 4. So we have 5x. When we find the derivative of 5x, we get 5x to the power 4. We have another scenario. If you have f of x equals to x to the power n, this will give us f prime of x, that is the fourth differential will give us c, which is a constant, will remain. But the x to the power n will apply the power rule on it. That is, the power will come down, n, x to the power n minus 1. And the two, you multiply them, if it's possible, c times n. An example is given there. We have f of x equals to 2x to the power 6. F prime of x will give us this 2, f prime, the fourth differential of x, will give us the power there that we have there is 6, will come down, so we'll have 2 times 6 to the power x, x to the power 6 minus 1. 6 minus 1 will give us the power 5, 2 times 6 will give us 12. So this, what we call the power rules. So it's important you understand them, so that when you get to example, you understand better. We have the constant rule. If you are given a function that is a constant, y equals to 2, or we have another constant here, y equals to negative 1000, y equals to 0.757, or you have y equals to pi, because pi is a constant value, or y equals to a fraction, 1 over 2. All these functions have the same derivative. Their derivative is 0. Why do you think this is? Think of the meaning of a derivative and how it is applied to the general graph of each of these functions. That is, if you are given a function that is a constant, on a graph, the value of the constant, if for example we have y equals to 2, say this is y1, y2, y equals to 2 will just be a straight line. It's parallel to the x-axis. So it is constant, really like a slope there. It's constant there at all points. So the derivative of this point is always, there is no gradient, there is no slope. So it's always equal to 0. So if you are given any function that is a constant, if you find the derivative of a constant, it's always equal to 0. So the derivative of all constants is equal to 0. Find the differential of it, you will get 0. The sum and difference rule. If you are given a function y equals to f of x plus or minus g of x, to find y prime, the fourth differential y prime, that's equals to, you differentiate f of x plus or minus, you differentiate g of x. That means you differentiate them separately. Y equals f of x plus or minus g of x. Y prime will be equals to f prime of x plus g prime of x. So e.g., an example is given. If you have y equals to 2x to the power 3 minus 5x squared, y prime y prime, the first differential of y will give us, the power there is 3. You bring 3 down. So it will be 2 times 3, 2 times 3, x to the power 3 minus 1. Always we subtract 1 from the power. We differentiate the second one separately, minus 5 times 2, x to the power 2 minus 1. 2 times 3 will give us 6. X, 3 minus 1 will give us 2. So 2 times 5 will be 10. And 2 minus 1 will give you the power 1 there. So if you are given a function y equals to 2x to the power 3 minus 5x squared, y prime, the fourth differential, will give us 6x squared minus 10x. Another example, example 2. A function is given. Y equals to 4x to the power 5 plus 3x. The power of x here, of the first term there, is x to the power 5. The 5 will multiply with the 4, 5 times 4, which will give us 20, x, but the power you subtract 1 from the power. That will be 5 minus 1, which is 4. And 3x, the power of x there is 1. 1 times 3 is 3, but 1 if you subtract 1, that will give you 0. X to the power 0 is 1, so automatically we'll get 3. So this will give us y prime equals to 20x to the power 4 plus 3. Practice. Take the derivative of the following. D over dx of 5. This 5 there is a constant. And I told you from the beginning that if to find the derivative of all constants is equal to 0. Any constant given, so the derivative of this will automatically give us 0. D over dx of 5 is 0. D over dx of negative 8 over 3, this is also another constant. There is no variable attached to it. So automatically, we are differentiating with respect to x. So this is also 0. D over dx of a function that is x to the power 5. If we differentiate x to the power 5, this will give us 5 x to the power 4. How do we get the 4 there? We'll bring down the 5. The power we subtract 1. So automatically, we'll get y is equals to 5x to the power 4. And if you are given a function that is d over dx of x to the power 3 over 2, this will give us, we'll bring down the power, that is 3 over 2, x to the power 3 over 2 minus 1. So if you subtract 1 from 3 over 2, there is 1.5, minus 1 automatically will give you what? Half. So this will give me what? 3 over 2 x to the power half. We have another function on the other side. The first differential d over dx with respect to x of 4x to the power 3. This will give us 4 times 3, the power, you bring it down, x to the power 3 minus 1. If you subtract 1 from 3, that will give you 2, so this will give us 12x to the power 2. Likewise, if I should take it down and solve, that is d over dx of x, 3x to the power half. That is, if you have, for example, d over dx of 3x to the power half, this will give us 3 times half of x to the power half minus 1. 3 times that will give us 3 over 2, x to the power 1 minus half will give us negative half. And negative half, we can manage it, that will come down. This will give us 3 over 2 x to the power half, which you can write, if you want, in other form, 3 over 2 root x. For this one, d over dx of x cubed plus 4x minus 5. If we differentiate them, this sum, use the sum rule, the sum and the difference rule. They are all addition here. You differentiate d over dx of x to the power 3 and d over dx of 4x and that of the constant separately. If you have to differentiate this x to the power 3, that will give us 3x squared, because the power will come down, 3 minus 1, that will give us 2. And that of 4x, this will give us plus 4, and the constant is 0. So the differential of this is equal to 3x squared plus 4. The first differential of negative x to the power 2 minus 1,000. 1,000 there is a constant, so it will give us 0. So all what we have to differentiate and find the value of is this negative x to the power 2. And if we differentiate this, it will give us negative 2x to the power 1, which is negative 2x. Let's deal with more examples and see. Extra steps. Sometimes it takes a little bit of manipulating of the function before applying the power rule. Here are 4 scenarios which required an extra step prior to differentiating. Before you differentiate a function like this, since we have not touched on other rules, you have to first expand this. To expand this function here, it means we'll have f of x is equal to x times x, that is x squared, plus x times 4 will give us 4x. Then we find the first differential. F prime of x now will give us, we differentiate d over dx of x squared there. X squared will give us 2x. And if we differentiate 4x, we get 4. For this one, we need to divide because we have f of x equals to 3x to the power 4 minus 2x squared plus 5x divided by x. X is common. It's a common factor for all of them. So we divide each term by x. So we'll end up with f of x equals to 3x to the power 3 minus 2x plus 5. X will cancel out one of the x here, and x will cancel out one of the x here, and this x and 5x there will cancel out. So at the end we'll get 3x to the power 3 minus 2x plus 5. So to differentiate, the first differential of this will give us what? F prime of x will give us, bring it down, that will give me 9x squared minus 2. Likewise, we have another function here, f of x equals to 1 over x to the power 4. This 1 over x to the power 4, we can write it in another form better. That is, we can write it in this form. In this is f of x, 1 over a number is to the power. So this is the same as x to the power negative 4. If the first differential f prime of x will give us, bring down the power, minus 4x to the power minus 4 minus 1 will give us minus 5. Likewise, this one here, the last one, this is the same as f of x is equals to the cube root of x, that is x to the power 1/3. 1/3, if you bring the power down, this will give us what? That is f prime of x. The first differential of x of this will be 1/3 x to the power 1/3 minus 1. And that will give us 1 over 3 x to the power negative 2/3, which I can simplify further. We have 1/3 x to the power minus 3 over 2. This will give us 1 all that over 3, find the cube root of x squared, which will give us our f prime of x. And that will be the solution to. We have another question, that is, what is the derivative of 5x cubed? If you are given a function, let's say y is equals to 5x cubed, the first differential of this, which is y prime, that will give us what? Bring down the power, multiply with the coefficient that we have in front of x, so it will be 5 times 3, will be 15x. 3 we subtract 1, so that will give us 2 there. So going through the option, we realize that you see that the correct option there is option E, which is 15x squared. Another example, differentiate with respect to x, 3x to the power 7. D over dx of 3x to the power 7 there. What will this give us? This will be equals to, bring that to 7, so it will be 3 times 7, that will be 21. X to the power 7 with minus 1. And that will give us 21 x to the power 6. And 21x to the power 6 is option C there. To another question. What is the derivative of 15? 15 is a constant. So if you have a function, f of x is equals to 15, which is a value. I told you the first differential, to differentiate a constant, always we get 0. Differential of a constant is 0. And The correct option therefore is D. The first option is X, 1, 14, negative 15, and 0. So D is the correct option there, which is 0. Find f prime of x if f of x is given. F of x is equal to 4x squared minus 8x. To find f prime of x, this will give us what? We multiply the power with the coefficient that we have in front of x, bring down the power. 2 times 4, that is 8. X, we subtract 1 from the power, so the power will be 1. Minus, the power here is 1, x to the power 1. 1 times 8 is 8, 1 minus 1 is 0. X to the power 0 is 1. So automatically we'll get 8x minus 8. And 8x minus 8, by going through the option B is the correct answer, which is 8x, sorry, option D, which is 8x minus 8. Another question to try, find y prime if y equals to x to the power 3 over 4. Y is given, y is equal to x to the power 3 over 4. So the first differential, that is y prime, therefore will be equals to, bring down the power rule, which is 3 over 4. X to the power is 3 over 4, we subtract 1. 3 over 4, if you subtract 1, you get a negative value. 1 is greater. So this will give us 3 over 4, x to the power negative 1 over 4. This, I can relate it in another form. Because we have negative, we can go down to the denominator. This will give us 3 ordered over 4 to the power, to the 4th root of x. 3 ordered over 4 to the 4th root of x. And the correct option there is option C, which is 3 ordered over 4x to the power 1 over 4 there. Which expression represents the slope at any point on the curve? That is, the function is given y equals to 3x in bracket x to the power 8 minus 4x to the power 7. To differentiate this, there's a hint. The hint is, first we have to distribute. We expand the bracket, and that will give us y is equal to 3x times x to the power 8. That will give us 3x to the power 9. We add the powers together. Minus 3 times 4, that is 12. X times x to the power 7 will give us x to the power 8. To differentiate this, that is y prime, will give us what? Bring down the power of x, that is 9 times 3. 9 times 3 will give us 27. X to the power 9 minus 1, which is 8, minus. We differentiate x to the power 8. 8 times 12 will give us 96. X to the power 7. So y prime will give us 27x to the power 8 minus 96x to the power 7. And going through the options, the correct option there is option B. Viewers, that is the end of the lesson. We'll stop here till we meet again next class. And we'll continue from where we stopped on derivative, that is differentiation. When we meet again, I'll stop here. You can stay home and stay safe. Thank you very much.